Welcome to the distance learning program on cloud computing by Innobus. In this chapter, we'll be checking at the Amazon Web Services, its products and services under the category database. AWS offers three different services in database category. First one is DynamoDB, and we have Elastic Cache, and they also provide RDS. Let's check what is AWS DynamoDB is. The AWS DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with a seamless scalability. Instead of using a traditional MySQL or Oracle DB based database system, we can implement DynamoDB for our database operations integrated with our web or mobile services. And it says DynamoDB is downtime free scaling. In other words, the scaling of DynamoDB is possible, and that too without a downtime. We can increase the performance of computing units, or the RAM used for it, or the total memory used for the DynamoDB. We can increase that without a downtime, and it's also maintenance free. We don't need to worry about the hardware provisioning, setting up the hardware, patch management, configuring the hardware, and replication management if we use a traditional database system. And in case of DynamoDB, we don't need to care about all these configuration and management hassles, since it's been handled by AWS itself. And it is powered by SSD, solid state drives. The data that we keep in our DynamoDB is being kept on a solid state devices, and which in terms gives faster data access, or let it be a write action or a read action, that can be more faster than other direct attached disk or any other storing medium. And DynamoDB is powered by SSD, and hence it results in a better or improved performance of data transactions. And also it says it provides durable storage, and how it does that is like the data are stored automatically across multiple availability zones for high scalability and availability. When we create a DynamoDB, we keep our data into DynamoDB, and these data are automatically replicated into different zones available with the Amazon Web Services. So our data always has a replication of the same under different zones. So the durability always is high with AWS DynamoDB. And it says there is less or no administrative burden. Why? Because we don't need to care about taking the backup and managing the server and managing the architecture, managing the replication, managing the backup. We don't need to spend time on all these categories, since it's been taken care of by Amazon DynamoDB itself. And it results in improved performance. As we have seen, it has its own compute power, and it stores its data on SSD, and the data is stored under multiple zones, so it results in an improved performance of data rendering. Now let's go ahead and check how can we create or how can we configure a DynamoDB in AWS. And let's also create a table in AWS DynamoDB. Let's log into our AWS Management Console, and in AWS Management Console, let's go ahead and click on DynamoDB. And in DynamoDB, as they have seen, it is a NoSQL based database. So the data that we keep in AWS DynamoDB is always stored on a table format. So we create tables in DynamoDB. So let's go ahead and create a table. And here it's asking for the table name, in which we can go ahead and store our data in the table. So we can give a name to identify our table. I'm going to make it as burst T1. And now we see that it's asking for primary key, and there are two types of primary key that we can select with AWS DynamoDB. First one is with hash key, and the second one is with hash key and range. The hash key that we use to identify the data with the primary key in the table, and with the range, what's the benefit is that when we write a query to extract data from the table, and if that queries are going to be longer, or if that has a lot of filtering actions, certainly we have to use hash with the range. So in this case, we can go ahead with hash, and the primary key, I'm going to give a string. The string is nothing but we can give a string, or we can select a number. I'm going to give it as string, and I'm going to give a primary key attribute name. We can go ahead and create it as items, and we click on continue. Now in AWS DynamoDB, while creating the DynamoDB, it will ask the user to allocate the provisioned throughput capacity. And what is the throughput capacity? The total number of read and write requests in a second. That's what Amazon AWS DynamoDB means by throughput. So if we are not clear with what could be the throughput for our transaction, we can go ahead and ask AWS console to check what could be the throughput. Here it's asking for the average item, estimated size of an average item. If the data that we keep on AWS DynamoDB, if there are details about employees or details about items in the inventory management system, that could be less than 1 KB. And so let's keep it as 1 KB. And what is the estimated items read or write per second? So we can say read per second. We can say that read per second would be 10 items would be read. And now it's asking for consistency. So before we check the consistency, we need to be clear what exactly the provisioned throughput means. Okay, when we create a table using the DynamoDB and we update our data in the DynamoDB table, and we say, or we inform the AWS that we need to allocate this much number of computing resources for our table to perform our data transactions. Since we are not clear what is the number of throughput we have used to calculate what could be the throughput. So when we complete the calculate, AWS will tell this is what the compute units required to perform the data transactions in our DynamoDB table. So we have given the read estimate, and now let's go ahead and give the write request. And we can also change the throughput that we are giving right now in the future if we plan to scale or change these expected number of read and write requests per second. And also we can see that it's asking for consistency, and there are two types of consistencies. One is strongly consistent and another one is eventually consistent. And the strongly consistent, it means to read the data, or the data that we keep on DynamoDB is being replicated between different multiple zones. So if we use a strongly consistent, the very next moment when we update the data, these data are replicated between the different multiple zones with our DynamoDB table. And if we select eventually consistent, it spends half of the effort which happens on strongly consistent. And it's also asking for what could be the estimate item written per second. I'm going to give it as 10, and we click on calculate. So it says the throughput capacity should be read write 10. So let's continue. Now it's in throughput, or while creating the DynamoDB table, it also gives another feature to the user. That means we create a table and we allocate that table and we integrate that DynamoDB table with our web application. At a particular point of time, if the number of transactions happening in our web server is going to be high, or if that results in a huge number of transactions, then the throughput that we set in the AWS Management Console. So the very next moment, we can get a notification from AWS DynamoDB, say like, this is what happens, this is what is happening with your database table. The incoming request seems to be higher than the throughput that we have set. So if we mention an email address here, the notification will be sent to us whenever the throughput becomes high. And we can also mention the range for this throughput. If we mention it as whenever the request exceed 80% or 75% or even 90% of throughput that we set, the very next moment we'll be getting a mail from AWS to our email address that we mentioned over here, that the throughput has been increased, the traffic has been increased than the throughput level that we have configured. So in this case, we don't need to set up an alarm over here since we are creating a sample table here. So let's click create. Okay, I'm going to uncheck it, don't use the basic alarms, and we click create. It may take a while, and it says it's creating the table, and we need to wait for a while. When it completes creating the table, we can refresh meanwhile. And here we can see that these are the details about our table in the DynamoDB. We can see what are the throughputs that we have created and when we have created that, and also we can set up the alarm. Even after creating the DynamoDB table, in the future, if we see or if we have to set up an alarm whenever the throughput increases or whenever the incoming traffic or number of transactions increase than the throughput that we set here, we can go ahead and click on use basic alarms and we can enable this alarm. And we also see that our table is now activated. So now let's go ahead and add data to the table using a PHP SDK that we have in my machine. And let's go ahead and add some data using the PHP put request put item command to this table. Now I got my Linux machine here, and let's go ahead and update some data into our DynamoDB table. And I've got the Amazon PW the PHP SDK in my machine, so I'm going to go to that SDK file. I've got the SDK here. Here we are going to see here's the SDK file for PHP which I have in my local machine, and I have created a DB file in my machine through which we can go ahead and update the data to our DynamoDB table. And I'm going to create a DB file, a sample DB file. So before we do that, let me go ahead and create a sample DB file here. I've created a sample DB entry file, a PHP file here, and I've mentioned our details which we need to update our Amazon DynamoDB. And let's go ahead and call this put function into our DynamoDB, and let's see whether we can update, whether we get this data entries that we have mentioned in the file to be updated on the file in our Amazon DynamoDB file. We log in back to our AWS Management Console and we go to the DynamoDB, and in the DynamoDB we can see that we have our table which we have created here. Let's select that table and let's click on Explore Tables. Now here we see there are items which we have updated into our DynamoDB, and the items are with the RAM. I've mentioned RAM, disk and processor as items with values, and we can see those values here. Also we can go ahead and list, if we have more than one table here, we can go ahead and list the number of items in the table with the hash key or with the key that we perform for the primary key, which is items in this case. And we go ahead and click on get, and we go to go and we type 9 here. It won't list anything because we have mentioned 10 as the key for the items entry. So we click 10 and it lists the number of data available on that table with the key 10. So also we can update data using the AWS Management Console. When we click on this put item, we can go ahead and add data. Let's go ahead and add some data like keyboard. Let it be string, and let's give a value 8. I'm going to give the value 15 for this attribute, and we enter an item mice and we give a value 7 and we put the item, and it says put item has been successful. So we go back to list and we explore the table and go ahead and click on get and we type 15. So it lists only the content that comes under the attribute 15 for the table items or the primary key items, and it lists what are the contents listed in that table. And this is how the AWS DynamoDB works. And also we can go ahead and delete the table that we have created just by selecting the table and then click on the delete table tab, and it will click on the delete table. Also delete the CloudWatch. CloudWatch is nothing but if we have enabled CloudWatch in our DynamoDB, if we have set alarms to monitor that, those alarms will also be deleted for this table that we have created. So we click on delete, and by then the table will be deleted and shows the status is deleting, and soon it will change to delete when it completes the deleting process in the DynamoDB from different multiple zones. And now the table that we have clicked for deleting has been deleted from our AWS Management Console. There are no more tables to list. Now let's go ahead and check what are the advantages of using AWS Dynamo. Now when it comes to advantages, we know that AWS DynamoDB is fast since it keeps the data in a NoSQL format in a table which can be accessed through the primary key and the hash, and as well as the hash and the range part, and it gets the data in a faster mode. So it is fast and it is easy to manage. As we have discussed before, we don't need to care about the hardware and its patch management and configuration management. No, everything will be taken care of by AWS when it comes to DynamoDB, and it's easy to manage. And when it comes to flexibility, yes, it is easy to manage, and since the data is replicated between different multiple zones, even if one zone goes down, we will be having our data stored in other zones which are available in the Amazon Web Services, and it's easy to manage in case of a disaster recovery, and it gives high consistency due to storing the data in multiple zones, and it's also scalable. As we have seen, we can also change our throughput value in the future whenever we are supposed to have a huge traffic or huge number of transactions, and we can also increase the storage. And as we have discussed, it it allocates, whenever we create a table, when we mention the throughput, it allocates the number of compute units required to perform the transaction based on our throughput value. And these allocations are always scalable. When we increase the throughput, the number of compute units allocated for that transactions will also be increasing. So, and it is scalable and it is secured. The DynamoDB transfers these data over an SSL channel and in an encrypted format. So the data which we keep in DynamoDB table are always secured. And it also provides a feature of monitoring through CloudWatch. As we have seen, we can get notifications on a particular event when it goes to more than 75% or 80% of throughput value which we set for the transactions which happens on our server. We get the notification, and also we get notified by the number of CPU usage or the total process happening or the total utilization of the DynamoDB that we create, the table or the transaction that happens on the table. Now let's take a look at another product in the database category from AWS, which is Elasticache. Before we look into the Elasticache, let's see what exactly the output of using the Elasticache. For improving the performance of our web application, we use the Elasticache product. And let's check what are the different scenarios in which the performance of our web service results in a negative or becomes slow. So we know that there are some major reasons for slow performance of a web service. One could be based on the internet connection, and second one based on the compute and the processing power of our web server. And after that, it comes to the database. And the database, how it becomes, how it makes our web service slow is based on the time the database server takes to process the incoming request through the web server. The time the web server or the time the database server takes to process the transaction results in the performance of our web service. And to increase that performance, we use Elasticache. And before looking into the Elasticache, we need to check what is memcached. We know that memcached is a component that we use in our server to increase the performance of the transaction which the database handles. And how it happens is like it creates a database caching. The query which comes between, or the transaction which comes between the database and the web server are cached using the memcached. And from there, the same queries will be answered, which automatically results in improved performance. And in Elasticache, what happens in the background is it creates or it caches the queries or the transactions between the web server and the database server. Now let's take a look at what is the traditional system does. We know that the client nodes which sends a request to our web server, for example Apache, and then Apache, the web server then sends a request to the database server. The database server then sends the output of that particular request to the web server, and then it's been handled to the node or the workstation from which it receives the request. And this is a normal scenario. In case if we have, instead of the 3 client nodes, if we have more than 100 or millions of client transactions simultaneously, we need to scale up the web server as well as the database server. It's pretty easy to scale up the web server with the use of auto scaling or load balancer or Apache clustering. We can scale up our web servers. But scaling the database servers is a difficult task. It is very much difficult to scale up the database servers, and that's why we use Amazon Elasticache. Okay, this is how it works. The Elasticache, it works in our web service, and whenever a query comes to the web service and it handles that to the database server. The Elastic Cache takes the copy of that input as well as the output from the database server. And whenever Apache receives the same request for or the same query which is supposed to get the same answer, the answer is being served from the Elastic Cache than from our database servers, which results in improved performance. Now let's go ahead and check how to configure and launch an AWS Elastic Cache through the AWS Management Console. Now we log into our AWS Management Console and we select the Elastic Cache. And before we go ahead and create a Elastic Cache cluster here, we need to know some other important points about Elastic Cache. As we have discussed before, in a traditional system we use the memcached technology. If we have a web service which is already implemented with memcached, we can also integrate Elastic Cache with that. It supports the services or the web server which has the Elastic Cache, the memcache installed on it. So let's go ahead and create a cache cluster. Here, first of all, it's asking for a name for our Elastic Cache cluster. I'm going to mention it as Inobus EL, and what type of node that we need. We can see that how much memory that we need for this cache, and if it is a small we get 1.3 GB of cache memory, and if it is large we get 7.1, and we can have up to 6.6 GB of Elastic Cache memory. So it's based on our requirement. We can select one out of it. So let's go ahead and select a normal small memcache, and the number of nodes that we need. If we select the 6 GB memcache and if we give a 20 or a 15 number of nodes here, we get 1 TB of memcache or the caching for our web service. So let's give, we need only one node for this video, and now it shows what is the engine it uses. It uses the memcached, and what's the version it uses 1.5. Why it shows this? If we integrate this to our web service which already has the memcached, if the engine seems to be the same, there won't be any conflict on integrating the Elastic Cache with our web service. And it shows the port in which we need to run the Elastic Cache, and also we can have an option to select from which zone we need to launch this Elastic Cache. Since we have select US East here, we can select any zones out of the US East. Let's go ahead and select US East 1D. And another option is that notification. Here also we get notification on particular event that happens on Elastic Cache. If we want to set up the notification, we can set it up, or else we can disable the notification. And also it also asks for what is the minor version upgrade. If we want to upgrade, or it only applies to the cache engine software, which in fact works in the background. So let's click it as yes, and we click continue. Here it's asking for us to select the security group. In the EC2 chapter, we have seen that we associate a security group to our EC2 instance. So those security groups instance will be listed over here. Imagine we have a number of EC2 instance running in our AWS Management Console, and we have number of web services running on those EC2 instances. So if we want to apply the memcache only for a particular EC2 instance, in that case we select the security group of that particular EC2 instance over here for the memcached. So in this case we have only the default one, since we have only one instance running in our AWS Management Console. So let's take it as default. And another option is like it's asking for what type of caching parameter that there's another group for caching parameter, which is by default the memcache 1.4, which is the engine as well. And also we get another option to select a maintenance window. If we give no preference, the Amazon Web Services itself will carry out the maintenance whenever it has to do some maintenance on the screen, on the Elastic Cache. And if you want to mention the window, you can go ahead and mention the time. In case of a critical business, we can mention off-peak business hour for this maintenance window. So here, let's go ahead with the no preference and let's click continue. Here, before we complete that, it shows the review of or the summary of the details that we have given. We have mentioned it as a small M1 memcache, and we haven't mentioned any notification for this, and we have mentioned the security group as default, and we click launch and we click close. Now we can see it is creating the memcache cluster that we have created. So if we click refresh, soon it may take a while for completing. It may take a few minutes to complete the creation process of the cluster. So when it completes the process, we can see that as completed and active. Now after 2 to 3 minutes, it says the cluster that we have created is now available, and here we have another options to modify and reboot the cluster, and also we can delete the cluster from here. And also on the left hand side, we can see the cache events. Whatever happens to the cache event, if any kind of patch update or any kind of failure will be listed in the cache event. Since we have just started it, it does not shows any more information about the events. And also it shows to which security group it has been attached over here, and we can also see what are the parameter groups associated with our memcache cluster. We can see the Bryant protocol, the cache, the centralized authentication systems, and what is the maximum item size that we have specified. It takes by default what is the memcache D 1.4 inch. It takes the default settings as well. If you want, we can go ahead and modify the same through the modify button that we see on the cache cluster here. Now we have created the cache cluster. Now let's go ahead and check what are the advantages of using the Amazon Elastic Cache. Here are the advantages of Elastic Cache, and it is simple, and as we have seen, it takes not even a 5 to 10 minutes to create the Elastic Cache or to configure the Elastic Cache in AWS Management Console. And it's simple and it is managed. The failure of any of the instances in the cluster is automatically detected, and they are automatically replaced by AWS Web Services in the cluster. And it is compatible with the memcache D that we have already on our web server, and it is elastic. As we have seen, we can go ahead and modify the number of nodes that we have attached to our cluster. We can add the number of nodes from 1 to any number that we want to attach to our cluster, and also we can change the memcache type from the memory size from 1.3 GB to 6.6 GB. We can change the type as well as the size of the memcache node that we select, and so we can say it is elastic. As we have seen, most of all the products in the AWS Web Services are elastic because it is one of the major feature which we get in the cloud infrastructure, and it is reliable as it replaces the failure of any node automatically. It is reliable and it's secure as well, since it communicates the transaction through the SSL terminals. It is secure. And another point of advantage is that it is cost effective. We get charged only for the time that we use. It is pay as you go mode. We don't pay for the resources that we don't use. We only pay for the resources that we use for the hours that we consume the resources. Now let's go ahead and check what are the other AWS products available in the database category. And it is RDS, which is a relational database system available from AWS. And let's take a deep look into what exactly the RDS and how it works. Here in RDS in AWS, it is a relational database system which supports most of all the famous or mostly used database systems like MySQL, and SQL Server and Oracle DB as well. And it also gives a benefit of separate compute units for database. Usually in the traditional way, we run the database as well as a web server in a single server, where the CPU as well as the memory utilization is being shared between the web server as well as the database. And more technically, we could say the HTTPD and the MySQLD is these services are sharing the performance of the CPU in which we run these services. So when we use the RDS, the advantage or the difference is that the MySQL service is being handled by separate compute units. It has got its own memory and compute units, CPU, as well as the storage. All are separated from our EC2 instance or any other server in which we have the web service running. And it supports, we have the SQL Server different versions and MySQL Server different versions, as well as Oracle DB different versions available running or installed on RDS, from which we can select the appropriate one that we need. And it is easy to integrate. We have a web service running on a particular server in a cloud infrastructure. We can add the RDS to that web service without much hassle. When we create the RDS, we get an endpoint name to access our RDS server, which is our MySQL server. We can add that as a host name for our MySQL server in the code where we have the DB details or the normal config.php in which we keep the database details, for example. And another feature of RDS is that it takes backups automatically. We can go ahead and set up, or we can configure the backup window while creating the RDS, for how many days we need to take the backup and for how many days we need to keep the backup. All these can be configured, and that will be taken, the AWS will be taken the backup of RDS database by itself on the time that we mentioned. Like a cron job, it does that automatically. And it's easy to administrate, since we don't need to take the backup daily, or we don't need to check the backup whether it has been taken. There is no need of an human intervention when we use the RDS. And it is a scalable database system. We can go ahead and select a normal database system for we can run and we can deploy our database in that. And in the future, we require to have a higher performance in the database services. We can go ahead and change the type of compute units in case of small or large. We can change the type of compute unit that we use in the RDS. It is scalable. And it is a multi-AZ deployment. It provides multi-AZ deployment. What means by multi-AZ is that when we create the database in the RDS system, the database is stored on multiple zones. So when we select the multi-AZ deployment zone, our database will be stored in multiple zones. Even if a zone comes down, or if there is a zone failure from AWS part, if we select multi-AZ deployment while creating the RDS, our database will be safe, since it has been deployed under different zones in AWS. Now let's go ahead and launch an RDS instance in AWS, and let's see how exactly it works. Let's log into our AWS Management Console, and let's click on the RDS, which comes under the database category. Here, when we create the RDS, we will be mentioning the password and the master user, for example, root, as usual when we create the same in a local server infrastructure. So let's wait until it gets loaded. All right, we got the dashboard for RDS in Amazon, and let's go ahead and click launch a DB instance. Same as like EC2 instance, a DB instance is also called as, the RDS is also called as an instance. So here, as we discussed before, it shows what are the options or what are the types of DB type or DB servers available in RDS. It has got MySQL and Oracle DB as well as Microsoft SQL Server. So let's go ahead and start with the MySQL database. So when we select the MySQL, it's asking for us to select what type of license mode. Since MySQL is an open source tool, we can go ahead and we select the general public license, and it's asking for you to select the DB engine version. In case of InnoDB as the MySQL engine, we can select which version that we need. For example, if you're planning to migrate a MySQL server from an in-house database to the cloud infrastructure, check the database version of the MySQL which is running in the in-house data center, and come to AWS RDS console, and we can select the same version, so that when we deploy or when we restore the MySQL dump, there won't be any more conflicts. So let's go ahead and select a DB version here, and the instance class. Here it shows what are the different class that we have. As we have seen in EC2 instance, it has got small, large, extra large, and extra large with 2 memories, and extra large with different type of memories. Let's go ahead with a small instance, and here what it says, you can opt for a multi-AC deployment or yes or no. If you select yes, our database will be stored in under different zones in AWS, and if you select no, it won't be stored in different zones. It will be stored only in the default zone that we select. In case of this deployment, it shows US East, so in that zone it will be automatically deployed. And now it's asking for you to select what is the allocated storage. So we can go ahead and type it as 5, since it shows 5 GB is the minimum. Let's give 5, or otherwise let's give 10 GB as the storage for our database. And here it's asking for you to select a DB instance identifier. We need to give a name for this MySQL DB instance. I'm going to mention it as InnoBus. Now it's asking for the master user name. We can give root as a master user, and we can mention a password. I'm going to mention a password. Okay, we have entered the password. Now let's click continue. Okay, we need to have minimum 8 characters, which is another security stage provided by AWS to keep the database safe and secure. Okay, I've entered the password, and we click continue. Here it's asking for you to create the first database that we need to create in our RDS database system. So let's go ahead and create the database, which is cloud, and port by default it's 3306, and since we are creating it as a normal, and we are not attaching this RDS to a VPC, so let's go, it's by default not in a VPC. If we have a virtual private cloud running under our management console, and if we want to attach this RDS to that VPC, we can select the VPC out of this drop down box, which will be listed automatically. And the availability zone, let's go ahead and create at 1D, or otherwise we can keep it as no preference, and let's click continue. Here, this is what we have seen before, the backup retention period. So if we give 10 days, the backup will be kept in RDS for the next 10 days, and we can have it up to 35 days. So let's go ahead and take it as 10 days. We need to keep the backup, or we wish to keep the backup for the next 10 days. And the backup window, if we don't make any preference, it will automatically take the database snapshot at a particular point of time as a cron, or else we can go ahead and mention the window. We can make it as start it as midnight 12 o'clock and duration is 30 minutes. We can also give whatever timing that we need to give. In case of a business which has enormous number of transactions per second, it's better to mention the off business peak hours over here, so that the protection won't be affected. And the maintenance window, as we have seen the Elasticache, the same. The maintenance window, we can mention the maintenance window at what time the patch update should happen. So we can mention our off business peak hours to perform the maintenance from the AWS side. So let's keep it as no preference for both, since we are creating a sample DB here, and let's click continue. We get a review here before we complete this, and we click on launch database instance. and we click on close. So while creating the database instance in RDS, it takes a while for completing the instance to be created. It may take several minutes to complete the instance to be ready to use. Now it shows creating, and we need to wait until it gets deployed and created and started state. Now we see that our RDS instance is now available. It has completed the creating state and now it's available to use. So when we click on the checkbox in our DB instance, we can see some details about our RDS instance. It says the DB engine and it shows at the endpoint. This is what we use to access our EC2, our RDS instance. And it says who is the master user. It never shows the password. And also we can go ahead and set monitoring here, as it shows the CPU utilization and what is the free average store, what is the free memory available in the 10 GB that we have allocated. And when we have read and write options happening in our RDS, we can go ahead and come to this AWS management console and we can see the average read write options or operations happening to our RDS instance and the latency and the throughput. All these informations can be seen from this management console. And the recent events in case of any failure or in case of any startup or in case of any backup, all those events will be listed over here. The finished backup is nothing but whenever we create the RDS instance with a DB, it creates a snapshot of that database as a backup, and that's what we see here right now here. So when we have a database backup to be taken at a particular time on a daily basis, those instances will be shown over here. We can go ahead and refresh on this button on a daily basis and we can see whether the backup has been finished or not for our RDS DB. So now we got the endpoint to access our MySQL server running in the RDS instance. Now let's go ahead and access this RDS instance and let's see whether the table test has been created or not. And before we try to access our RDS instance, we need to make sure that it has got enough permission to access it from the public internet. So we click on the DB security group on the left hand side and we select the security group type. So we select if we have a particular IP from which we need to have the transaction to be performed on this RDS, we can mention that IP address with a subnet, or else we can select our own EC2 security group. And let's go ahead and select security group which we have there and we click add. And if you want to add more security groups, we can also add more security groups into this. So this is how we add the security group to our RDS instance. And based on the security group filtering mentioned on our security group, the traffic will be permitted to our RDS instance. So now we have given permission to access to this RDS instance from the public internet using our security group. And now let's go ahead and try to access this instance. And to access our RDS MySQL server, I move to my Linux machine and I open the terminal and I go ahead and type MySQL, and we mentioned the host name, and host name is nothing but the endpoint that we have copied, and the user, which is the master user, which is the root, and we press enter and it's asking for the password. And when we enter the password, we wait. So now we can see that we have logged into our RDS MySQL server. Now let's go ahead and check whether we can see the database that we have created. It shows the cloud, the DB is the engine, and the cloud is the database that we have created. We can also go ahead and create a database here using the normal MySQL command. There is no difference. Only thing is that it's been stored under the cloud server, and the rest everything is same. And we can check whether the database has been created. Yes, the database has been created. This is how we create and access a MySQL server in the RDS. And this is how we access a normal MySQL server running on RDS. Since we have added the host name to access this particular MySQL server, we use the same endpoint name as the host name for the MySQL. In case of a normal web server, we might be having the MySQL running on the same server. So in the dbconfig file, we usually mention the MySQL as port 3306 and on the local host. So instead of that local host, we go ahead and mention the endpoint as the host name to access our MySQL running on RDS server. So that's how we access and create and deal with the MySQL database running on RDS. So now let's go ahead and check what are the advantages of using the RDS. The first advantage is that it is pre-configured. We don't need to enter or we don't need to install the database in the instance. It's already installed, and patch and the configuration management has been taken care of by AWS. So it's already pre-configured. We don't need to spend time on configuring our database, and it allows the monitoring feature. We can go ahead and check the different type of CPU utilization, IO writes, and everything on our RDS instance. I'll show you how to see that. Now go back to the AWS Management Console and to the RDS tab. Here, when we select our RDS running, we go ahead and look at the bottom. We can see the details mentioned about our RDS instance, including the endpoint name, which is very important. And we can also see the tab which is called monitoring. So if you click on the monitoring, we can see different monitoring which is by default happening, and the CPU utilization, what is the CPU utilization, and what is the free storage available in our 10 GB database, and what is the memory, and what is the average DB connections. Since we had only one connection now, it shows the count, and the average IO writes and the average IO reads, including the latency and the throughput. So these monitorings are by default there for your MySQL server running in the RDS, and that's why we say the advantage as it is monitoring enabled. And the automatic software patching is happening. We don't need to manage the configuration and the patch update. It will be taken care of by the AWS services, and it is scalable. As we have seen right now, we have selected an RDS and we have launched the RDS instance with a small instance of 1.7 GB RAM with a single compute processing unit. And these are scalable. We can stop the instance and we can change the instance type from small to medium and to large, or from small to large based on our requirement. And it has a feature of automatic host replacement. In case of any hardware failure in our RDS instance, Amazon automatically detects it and the host will be replaced automatically, and our data will be persistent. And it is inexpensive because our RDS is taking care of our database server. At the same time, it also takes the backup of our database based on the backup window that we set as a cron job. So both are being taken care of by AWS. In other words, we have to, or in the traditional way, we need to search for the MySQL server and also for a backup partner where you can take the backup. So in this case, it's been taken care of by a single authority, AWS, and it is inexpensive. So that's all about the store database products available from AWS services.